Hey everybody, welcome back to Number Sense Academy, and right now we're going to take a dive into line segments. This is just a continuation of the stuff that we've done for lines, and this topic is lin or like I said, line segments. And if you think about or just look at the words that we have, we know that we're dealing with a line, obviously, and then a segment. So a segment would be just a portion or a part of a line. So we're actually looking at taking our typical line and then breaking it out into parts or pieces or components, whatever you wish. So that would be a part of the line. That would be a part of the line. That would be another part of the line. And these are just parts of the line because the arrows tells me that this thing goes on forever. Or I could have a part of the line that looks like this. Right? Now, the one thing or a couple things that we should point out about line segments, just some properties. And the first thing is that you see the way I've been drawing the segment to show that I'm taking a portion of the main line, is that line segments, they have two endpoints. And we normally signify them with either closed circles or open circles. It depends what the context is. The second thing is that they have length. In some case, we could call it distance. Look at some of the other videos where we actually calculate the distance of a line segment. Same thing as the length. And the other thing is, as it pertains to a line itself, it has some of the properties of a line, which also includes it has the same slope. So it's the same slope, which means that it has the same direction and magnitude and steepness. When I say magnitude, maybe not magnitude, I don't know why I said magnitude. Steepness is more like it. And I want to point that out, and I'm just going to stress that out here a little bit. So if I have a line that looks like this, and I have 2 points on this line, right? And this is the slope of the line that I derive from these 2 points. These 2 points signify a segment of the line because I could take any 2 points. Any 2 points. That's a bad color. Any 2 points will have the same slope. Any 2 points will have the same slope of this line. Any 2 points. Okay? So any 2 points form a line segment, two endpoints form a line segment, and therefore any 2 points on a line will have the same slope as the main slope. Now, there's one more thing I should point out about the line segment, particularly for this lesson, is that if I have a line segment and I cut it in half, this is called the midpoint, right? Or you could call it the halfway point. Whatever you choose. Midpoint, halfway point, same thing. And basically it cuts the line in two equal parts. Right? So the distance from here to here is the same as the distance from here to here. Oh, that was drawn really poorly. Right? So whatever the total distance is, I split it in two, and I share the distance among each segment. So that's the midpoint. And this has very useful values, or very useful properties, or useful use cases, if you will. And we're going to get into some examples. But first, I want to show you how we calculate the midpoint. So we calculate the midpoint using this formula, M, and we say the midpoint of 2 points, so x, y, um, is equal to, we're going to take the sum of the x values, We're going to divide that by 2. And we're going to take the sum of the y values and divide that by 2. So I have x1 plus x2 divided by 2. That gets me the halfway point between the two x values, and you must add them. Then I take the y values, I add them, and I divide by 2. The reason I'm stressing that you must add them, because it's very easy to mistake it for the slope formula. I've seen people do this over and over because they see this minus sign and they see the x and the 2 and the y and the y1 and the y2 and the x2 and the x1, and it's easy to get these confused. Another thing to remember is that whenever you calculate the slope, you end up with a real number, or you end up with one value. With the midpoint, you're going to end up with a coordinate. So this is going to pertain to the x value of the coordinate, and the y computation, y1 plus y2, will pertain to the y value of the coordinate. Slope gives you a value. That's rise over run. Midpoint gives you a coordinate. You could locate the midpoint. And these two are going to work in tandem to help you find equations of a line. If you recall, to find the equation of a line, all you need is one point and the slope. Once you have those, then you can find the equation of a line. So let's jump into some quick examples to get a hang of this. So the first example we have, it says to find the coordinates, or the coordinates, of the midpoint for the following. And pardon the scripting, it's terrible. So I have A, and that's going to be -2, 7, and I have B, 4, 7. Okay, so I'm going to find the midpoint. So we're going to say M is equal to x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So this is going to give me, I'm going to locate my values. Let me just make this point clear. When it comes, because we're adding, because it is adding, we don't need to, it doesn't matter what you assign your x1, x2 to. So if you remember with slope, whenever you assign your values, right, or you could write it as y2 minus y1 over x2 minus x1. If you have, say, 1 and 2 and then 3 and 4, you cannot do x1, y2, x2, y1. You can't do this. This gives you different values than if you were to assign it as x1, y1, sorry for that, x2, y2. With the midpoint, it doesn't matter because you're adding. So you could write this as x1, y2, x2, y1. It doesn't matter. Or you can write it as x1, y1, x2, y2. It doesn't matter because you're adding. Right? So just keep that in mind. All right, so let's plug our values in. So x1, I'm going to write it as -2. I'm going to add 4 for x2, and I'm going to divide by 2. For y1, I'm going to take 7. I'm going to add 7 for y2, and I'm going to divide that by 2. So I end up with 4 minus 2 is 2, so I have 2 over 2, and 7 plus 7 is 14, and that's over 2. So I end up with a coordinate of 1 and 7. Okay, so the coordinate for the midpoint is going to be 1 and 7. All right, pretty straightforward example. So let's do this example. So it says determine the equation of the perpendicular bisector of a line segment with the following endpoints. And the endpoints are f is 1, -3, and then g, write that better, g is 2, 2. Okay, so we know that we have a line segment that has these two endpoints. All right? And we want to find the equation of the perpendicular bisector of the line segment that has these coordinates. So if you want to put it on a graph to do it, great, but you don't have to, because what we need to do is first, we're going to do a couple things. So let me just write those down. So the first thing we're going to do, because of this word perpendicular, we know that we need the slope of the line, right? And then that's going to help us get the negative reciprocal, which is going to be the slope for the equation of the perpendicular bisector. And I should point out that perpendicular bisector, that means it cuts the line in half and it's perpendicular. So you could have a line that connects to the midpoint of another line, but they're not perpendicular. These are not perpendicular. Okay, but this one is perpendicular because it hits it at a 90-degree angle. So that's important. Okay, so we know that we need the slope of the first line with with f and g with the endpoints that are given, and then once we're going to take that, then we're going to find the negative reciprocal to get the slope of our perpendicular bisector. And then the other thing that we need to do, we're going to use y minus y1 is equal to m times x minus x1 to get the equation. But our y1, these values, this comes from the midpoint. All right, so there's a couple things that we have to do. First, we need to find the slope, and then we need to find the midpoint. So let's just jump into that. So let's find the slope. So the slope we know is y2 minus y1 over x2 minus x1, and that will be, so g was going to be my subscript 2, or my x2 y2, and then f will be my x1 y1. So we're going to have 2 minus 3 over 2 minus 1, and that gives me 5 over 1, which is 5. The negative reciprocal of that is going to be negative 1 over 5. Okay, so remember, this is the slope of the perpendicular bisector, negative 1 over m. So I need negative 1 over m. M is 5, negative 1 over m is negative 1 over 5. And then the next thing I'm going to do, just get some real estate there, is I'm going to find the midpoint. So we know that's x2 plus x1 over 2, and pardon the writing, y2 plus y1 over 2. And you see how I'm kind of mixing it up because it's communicative, or communicative? I think that's the word. Commutative. My goodness. Commutative is the word. Doesn't matter what the order I put it in. So I'm going to write it as, so x2 is going to be, either way it's going to be 1 plus 2 over 2 and then y is going to be negative 3 plus 2 over 2. So this becomes 3 over 2 and negative 1 over 2. So that's my midpoint. This is the point that connects both the perpendicular bisector and the point that has these two endpoints. Okay, this midpoint sits on this line, and it also sits on the perpendicular bisector. So with this information, I can now find my equation. I'm going to use this to find my equation. So I end up with y. Let me save some room here. So I end up with y is equal to, I'm still not writing this properly. So y minus y1 equals m times x minus x1. So plug what I know. I don't know what y is, but I know y1 is negative a half. And then m is negative 1 over 5. And x is 3 over 2. Negative 1/2 and 3 over 2 come from here. And negative 1 over 5 comes from here. So I end up with y plus a half equals negative 1 over 5x is going to be negative 1 over 5x. So this is the slope part of my equation. And then I have negative 1 over 5 times negative 3 over 2 is going to be plus 3 over 10. So now I have y is equal to negative 1 over 5x plus 3 over 10 minus 1/2. All right, and if you plug 3 over 10 minus a half into your calculator, you will end up y is equal to 1 over 5x. So 3 over 10 minus 5 over 10 is going to give me negative 2 over 10, which is the same as negative 1 over 5. Okay, so if you're not comfortable with the fraction component, then you have to get comfortable with that. So it's going to be 3 over 10 minus a half. A half is the same as 5 over 10. Right? 3 minus 5 is going to be negative 2 over 10. And then you could reduce this to negative 1 over 5. And that is that. So here's one last example to wrap this up. And this is sort of a complicated example, and I'm going to try my best to go through this as clean as possible without making it too confusing. And the main purpose of this equation or this question or problem is to show you how you could go about solving the problem. So let's see. I'm going to write it out. A quadrilateral, not a quadrilateral, specifically a rectangle has the following coordinates. So we got A is negative 3, 1. B is 3, 3. C is 4, 0. And D is negative 2, negative 2. So we want to determine the equations of the perpendicular bisectors. That's one. Then we want to find the point of intersection for the two perpendicular bisectors. And then we're going to check that our solution is true. All right, so first, before we get into this, let's discuss a few things. We got some vital information here. One, it's a rectangle. Why is that important? That's probably the most important thing that we need to know. A rectangle has 4 sides. The vertices, and it also has 4 vertices. The vertices are these things where the lines connect and intersect. Because it's a rectangle, all of those vertices are 90 degrees. Okay, so they're perpendicular already. The angle of those vertices are 90 degrees. Second thing, you have 2 sets of parallel lines. So the opposite sides are parallel. Opposite sides are parallel. So if you could reason this out, then this helps a lot. So we know that there's 4 sides, 2 sets of parallel lines. So this side is parallel to this side, and this side is parallel to that side. Parallel lines have the same slope. Parallel lines have the same slope. So let me just jot that down somewhere. Parallel lines have same slope. Perpendicular lines have negative reciprocal slope. Perpendicular lines have negative reciprocal slope. All right, so what's the value of all this? So this is going to tell us how we're going to solve this problem of we got to find these equations of the perpendicular bisectors. We got to find the point of intersection for the 2 perpendicular bisectors, and then we're going to check to make sure our answer makes sense. So the perpendicular bisectors, as we know, they're just the midpoints. So in that case, I would have a midpoint here, and I'd have a midpoint here. All right. And then if I connect those, that would be my line segment going in that direction. I also have a midpoint here and a midpoint here. So I have midpoint 1, midpoint 2, midpoint 3, midpoint 4. So with that information, if I have the midpoints, then what I need to do is find the equation of this line. What I need is the midpoint of this line and the slope of this line. Because if I have the midpoint, then I have my point that that's connecting this line right here, which with this line is running horizontal. And then if I have the slope of this same line, then I could take the negative reciprocal, and then I could find the equation of this line. I could also find the slope of this line because it's going to be parallel to this line. Right? They'll be the exact same thing. But I'm going to you did get to decide what you want to do because you want to be as efficient as possible. Now when I go to the other line, which is this line, that is also that's running parallel to this line. So once I have this line, I already know the slope of this line. And then all I need is the midpoint of these 2 lines. So I really only need to calculate the slope once. I just need one slope. I need one slope value, and in this case, I need one slope and I need two midpoint values to find the two equations of the perpendicular bisectors. Then, to find the intersection of the two perpendicular bisectors, which is going to be right here in the middle, I just need to take the midpoint of this line going vertically, right? Or I take the midpoint of this line going horizontally. The challenge there is now I need two sets of midpoint to find this midpoint. I need this midpoint and this midpoint to be able to find this midpoint. I could do that calculation, or once I have this equation and I have this equation, I just find their point of intersection using substitution or solving a linear system. All right. So let's give this a tackle. And then to check that our solution is true, we are going to have to go an extra step depending on how we go about this. Either we find an extra midpoint and then we use substitution to check that our answer is true, or we're using a substitution and then we find another midpoint and then find the other midpoint to find the answer. So this is a hella confusing. So let's jump into that real quick. So I could, but if you feel comfortable, put it on a graph just so you see what you're working with. But we don't need a graph. So let's tackle this. It actually would help. You know what? Let's put it on a graph, because putting it on a graph, we actually know how the labels connect. So we have A, B, C, D. We need to see what they look like. So let's put it on a graph. So that's the first thing we're going to do. Y, X. My biggest Y value is 3. I'm going to keep this simple as possible. 3. My biggest X value is 4. One, two, three, 4. My smallest X value is -3. 1, 2, 3. And then my smallest Y value is -2. 2, -1, -2. So let me graph that real quick. So I have point A is -3 and 1. So -3 and this is 1, 2. -3 and 1. So I have a point here. That's point A. Then I have point B, which is at 3 and 3. So this is about here. And this might not look terribly great just because it's not scaled well. And then point C is at 4 and 0. So that's right here. So that's C. And then point D is at -2 and -2. So that's about here. That's D. And I'm going to connect them. Okay, I'm going to connect them. So I see that I have a line AB. This is AB, BC, CD, and AD. So what I'm going to do now, I'm going to create 2 other lines because I need a line point here and a point here. That's probably the midpoint-ish. It's looking midpoint-ish. I'm going to call that E, call this one F. I'm going to call this one G, and this one H. If you remember what we did in the previous slide with the example of a rectangle and how we show how each parts are connected. So what I need for this, I'm going to find the slope of AB. The slope of AB, all I need is one slope, because the slope of AB, because AB is parallel to GH, which is our new line that we pointed out. It's also parallel to CD. So that means they all have the same slope. All of these have the same slope. Okay? But AB is perpendicular to AD, right? Which means that AD and because these are parallel, AD, BC are parallel, and EF, because these are parallel, then they're going to have the negative reciprocal slope of AB. I'm going to write that down. Negative reciprocal slope of AB. All right, so that's taken care of. Okay, so let's do that then. So I have M is equal to, we know it's y2 minus y1 over x2 minus x1, and AB, so that's going to be uh, 3 minus 1 over 3 plus 3, which is equal to, wait, which is equal to 2 over 6, which is equal to 1/3, right? So if this is the slope of AB, that means the perpendicular slope must be -3, all right? So for AB, AGH, and CD, M is equal to 1 over 3. And for AD, BC, and EF, M is equal to -3. Great. So now let's find the midpoint of AB. So the midpoint of AB is going to be -3 plus 3, and I'm just jumping straight to the values, 1 plus 3 over 2. So this becomes -3 plus 3 is 0, so this is automatically 0. And then 3 plus 1 is 4 divided by 2 is 2. So that's the midpoint, right? So with that, this is the midpoint of AB. I should be specific. The midpoint of AB. With that, I could find the equation of the line for EF, right? So, but I need to, so let's do that, just so I get that out of the way. So the equation for EF is going to be, I'm going to call it, I'm just going to write it out. So Y, so I'm finding the equation now. It's going to be Y minus Y1 equal to M times X minus X1. So I have Y minus, so I'm using the midpoint of AB to find the equation for EF. Okay, so the midpoint is 0, 2. So Y minus 2 is equal to, remember the slope of EF is -3. We got that over here. -3, and then X minus 0. So I have Y minus 2 equals -3X, right? Because -3 times 0 is 0. So I end up with Y is equal to -3X plus 2. This is for EF. Yay, that's good. I'm glad that's out of the way. So now let's jump over to finding the equation for GH. So I already have the slope for GH. It's 1 over 3 because it's parallel to AB. So all I need to do is find the midpoint. And I'm going to find the midpoint of AD right here. So the midpoint of AD is equal to -3 minus 2 over 2. Okay? Negative 3 minus 2 over 2. And then I have 1 minus 2 over 2. So this becomes negative 5 over 2 and negative 1 over 2. I already have the slope. The slope, we know it's 1 over 3. So now I use my formula. I'm going to write in red. Y minus y1 equals m times x minus x1. This becomes y minus negative 5 over, nope, it's y, just negative a half is equal to m, which is, not writing m, it's 1 over 3 times x minus 5 over 2. So it's getting a little bit tight here. My apologies. So now I have y plus a half is equal to 1/3 x plus 5 over 6. 1/3 times 5, negative 5 over 2. This becomes positive because of these two negative signs. 1/3 times 5 over 2 becomes 5 over 6. So I end up with y is equal to 1/3 x plus 5 over 6 minus a half. So when I work out that math, I end up with 1/3 x plus 2 over 6, which is the same as 1/3. So now I have these two equations. Yes. I have these two equations. So I need to find where they intersect. I'm gonna find it the hard way first. And since I'm running out of real estate here, I'm gonna try and find as much space as possible. I'm gonna find it the hard way first, and then I'm gonna do it the easy way after. So what you need to do is to be able to find the easy way the whole way through. Okay. So the hard way would be to, actually, you know what? Yeah. I'm going to have to change slides, which means we're going to lose some of this info. Unless, pen. Yeah, I'm going to lose some of this info. Yeah. So remember, we have an equation of y is equal to negative 3x plus 2. And then we have another equation, y is equal to 1/3 x plus 1/3. So because they're both equal, this is saying that y is equal to y. So that means I could just write them as equals. So negative 3x plus 2 equals 1/3 x plus 1/3. And I solve for x, so I have negative 3x minus 1/3 x equals negative 2 plus 1/3. So you're dealing with a lot of fractions here, and that could get tricky. But I know that negative 3 is the same as negative 9 over 3. And negative 2 is the same as negative 6 over 3. Okay, so if you're having trouble with those fractions, then all I'm doing is taking these whole numbers and seeing what do I have to divide, what number do I have to divide by 3 to get negative 2, which is negative 6. What number do I have to divide by 3 to get negative 3, and that will be negative 9. So negative 9x minus 1/3 x, this is going to give me negative 10 over 3x, which is equal to negative 5 over 3x. And if we work this out, we end up with negative 10x equals negative 15. Nope. Yeah, okay, yeah, we'll leave it at that. negative 10x over 3, which means that negative 10x is equal to negative 5, and then x is equal to, yep, negative 5 over negative 10. X is equal to 1/2. Okay, so now to find y, I'm going to sub x equals 1/2 into any one of these equations, and I'm going to go with the first one. So let me call this 1, call this 2, sub it in 1. So I end up with y is equal to negative 3 times 1/2 plus 2. And this is equal to y is equal to negative 3 over 2 plus 2. So y is equal to, what number do I have to divide 2 by to get 2, which is 4. So negative 3 over 2 plus 4 over 2. I get y is equal to 1 over 2. So my intersection point is, this is my solution. xy is equal to 1/2 and 1/2. Now remember, the question said to check that this is true. So we're saying, if you guys remember the graph, this point here is 1/2, 1/2, right? And what we had was, that's this point. So we knew the corners. Remember, we had values for the corners. We calculated this, and remember it was 0, 2. We also calculated this, and this was negative 5 over 2, negative 1 over 2. Right? So I have an option. I could find this point, or I could find this point. Regardless, their midpoint, the midpoint of this line is the midpoint of that line. So I just need one more extra point. Okay, so I'm going to again find some room here, and I'm going to get that done. I just need one more point, and then I'm going to find out if the midpoint of those 2 points equals this middle point. So I'm going to do that on a separate page. So I know that I have the midpoint of AB was 0, 2. Remember that. And the midpoint of AD was negative 5 over 2 and negative 1/2. The midpoint of CD is, I'm going to find that one just because I know it's going to end up with whole numbers. If you think about how the graph looked, AD was parallel to BC, and AD had a midpoint that had fractions in it. Chances are BC will have fractions. So I'm going to go with CD. So the midpoint of CD is equal to, it's going to be 4 minus minus 2, or sorry, 4 plus minus 2 over 2 divided by 0 plus minus 2 over 2. So this becomes 2 over 2 and 0 over 2, which is the same as 1 and, okay, I think I made a mistake somewhere. No. 0 minus 2 is minus 2. Yeah. Yeah, be careful. So easy to make mistakes. 0, 2 is minus 2. So this becomes 1 and negative 1. So we want to find the midpoint of EF. If you recall that the points are, they are 0, 2. This is E. And F, which is the midpoint of CD, is 1, -1. So let's see what happens here. We have 0 plus 1 divided by 2. And then we have 2 plus minus 1 divided by 2. This becomes 1 over 2. 2 minus 1 is 1, so I end up with 1 over 2. So boom, it works. So just to sum this up, the first thing that we did was we made the graph, we graphed it, or we reasoned out what a rectangle was, then we graphed it and made sure that the properties held up for a rectangle. Then we determined, okay, we know that there's relations between perpendicular lines and parallel lines. So we use those relationships to determine the slope, which means we only have to find one slope. We could have solved for 4 slopes, but that would be a waste of time. So we solved for one slope, and with that, we knew the slope of the other line that was parallel, and we knew the slope of the other 2 lines that were perpendicular. Then we found the midpoint of one line, and we used that to find the equation of EF. And then we also used the information that we had from the slope of the perpendicular line, and then we found a midpoint, and we figured out what that equation was. And then we used substitution to find the point of intersection, and we checked that the midpoint was the same as that point of intersection because we knew that that midpoint was the point of intersection, and it should carry the same value, and it worked out. Thank you.